Okay, year 11. I'm going to go over the last question from exercise 212 that I want you to have a look at before you get to class tomorrow morning. By the way, we'll be in UG4, not upstairs. So question 10. We started this off. I want to make sure you finished it. We have three equations. 2a minus 7b plus 3c equals 7. A plus 3b plus 2c equals -4. And 4a plus 5b minus c equals 9. Double check those to make sure that they're right. Now, usually with these, what you've got to do is you've got to use a process of elimination to get rid of one of the variables so that you get two equations with two variables. We currently have three equations with three variables. Now, to eliminate these, we're going to have to do a combination of a few. But first of all, we need common coefficients. That means the same coefficients in front of one of the variables, one of the pronumerals. Now, personally, I would have gone with C, but you guys all wanted to go with A. So we're going to go that way. So to get them all in the same A, I'm going to get them all to be equal to 4A. So that means equation number 1, I'm going to multiply by 2. So that's going to be 4A minus 14B plus 6C equals 14. I multiplied every term by 2. Now, even though that is the same equation, it's just 2 times as big, I'm now going to call it number 4 because I'm going to be referring to it. Now, to make equation number 2 into 4a, I'm going to multiply it by 4. So I'm going to multiply every term by 4. So let's look at equation number 2. 4 times a, 4a. 4 times 3, 12b. 4 times 2, 8c. And 4 times 4, -16. And again, it's the same equation, just 4 times as big, but I'm going to call that equation number 5. Now, all I'm dealing with are these three equations, which are essentially the three original equations. I've just changed the way they look. Right, I need to eliminate the 4a. Now, you can do the 3 and the 4 and the 3 and the 5. You can do the 4 and the 3 and the 4 and the 5. Or you can do the 5 and the 3 and the 5 and the 4. We were in class and we decided we're going to try and use equation number 5 and subtract the two other ones from it. So I'm first of all going to go equation number 5 minus equation number 3. And here I go. So you've got to work this upside down. So the 4a's will cancel. I get 12b minus the 5b. 12b minus the 5b. And that gives me 7b. I get 8c minus c. So that's plus 1c. So I get 7b plus 9c. And I get minus 16 minus 9. -16 minus 9, -25. And again, this is a brand new equation. It's equation number 6. But see, it's only got two variables. Here we go. Now I'm going to do equation number 5 minus equation number 4. So 4a minus 4a goes 12b minus -14b is plus 14b. I get 26b. 8c minus 2c, 6c is 2c. I'm going faster than my head. Minus 16 minus 14. Okay, so -16 minus 14, -30. So now I've got these two equations. I'm going to call that question 7. And now I have two equations with two variables. I'm just dealing with these two. And again, I know some of you are going to jump in and try and do substitution. Right? You're going to write c is equal to something. But it's so much easier to make these two into something else by multiplying and eliminate. Now, I'm not going to do the b's because I've got a 26 and a 7. I can easily make the c's into 18. 2 and 9, 18. So equation number 6 times 2 gives me 14b plus 18c -50. And again, we're going to be referring to this. Look at this. We're all the way up to equation number 8. Now, I'm going to do equation number 7 times 9. So this is a little bit harder. 9 times 26. Oh, goodness me. 9 sixes, 9 sixes are 54. 9 twos are 18. 230. I'm just going to double check. 9 times 26. Yeah, 234. So 234B. And 9 times 2, 18C. 9 times 30, negative 270. This is now equation number 9. I reckon we could have avoided all this if we'd gone with the C's, by the way. So now my 18s are done, and now I can just go equation number 9 minus equation number 8. So 234 minus 14 is 220b. The 18c's cancel. 270 negative 270 minus negative 50 is negative 220. So B equals negative 1. Whoa! I'm just going to check on the answers. There we go. Now, you can use any equation, right, to get this. I'm going to use equation number 7. It doesn't matter. I'm going to sub this into equation number 7. So equation number 7, 2b plus 26b plus 2c equals 30. So 26 times negative 1. Let's make it small. 26 times negative 1 plus 2c equals negative 30. So it gives me negative 26 plus 2c equals negative 30. So add that 26 over. 2c equals negative 4. C equals negative 2. Now, because we've done so much manipulation with all these different equations, I'm going to go right back and I'm going to use the original equation. So what do we have? B equals negative 1, C equals negative 2. Now, we need to find the A. So obviously the best one to sub it into is number 2. So sub into 2. And we get A plus 3 times negative 1 plus 2 times negative 2 equals negative 4. A minus 3 minus 4 equals negative 4. A minus 7 equals negative 4. Add the 7. A equals 3. Now, as I said, you should not be getting any of these wrong. I'm going to check in both the other equations. Now, because I've got this A from equation number 2, I'm going to check in 1, and I'm going to check in 2, because this has been a long one. So we've got A equals 3, B equals negative 1, C equals negative 2. Are we correct? And we just have to establish that we're right. So 2 times 3, this is equation number 1, 2 times 3 minus 7 times negative 1 plus 3 times negative 2. Well, 2 times 3 is 6. Minus 7 becomes plus 7. 3 times 2 is then minus 6, which equals 7, and that's correct. Let's check in 2. And equation number 2 was, oh no, we're going to check in equation number 3, because we used 2. So 4 times 3 plus 5 times negative 1 minus negative 2. Well, what does that equal? 4 times 3 is 12. 12 minus 5 plus 2. 12 minus 5, that's just going to be 12 minus 3, that should be 9. Hooray! Right, bang, correct. So our solutions are A equals 3, B equals -1, C equals -2. Now look, I know that is a lot of work, but you need to set it out and show your logic and your working so that an examiner can follow what you're doing. It's so easy to make a mistake somewhere along the line. Good luck with that.